And then you're going to have some problems with solving systems with 3 variables, which is what we're going to go through a few examples today using systems with 3 variables. Okay? So if you have 3 unknown variables, you're going to need 3 separate equations. In section 4.1, you had 2 unknown variables, so you needed 2 equations. So instead of having x and y as your answer to your system, now you're going to have what's called a tripled order. Instead of an ordered pair, you're going to have a triple order. And it's going to be x, comma y, comma z, which just puts us into the 3-dimensional world.
Isn't that the thing where it's like it's a big table that you got to be working with in this one?
Big table.
I remember last year we had to work with a big table with an x, y, and z, and it was
Maybe. I mean, I'm not going to be using any tables, but yeah, you need to. It's a lot more work.
Yeah, I have to actually look at it and be like, this is what it is.
So we're all used to 2-dimensional coordinate grids, x and y. So what's happening is you have your y-axis, your x-axis, and you're going to have now a z-axis that shoots directly at you. So if you can envision an axis going straight towards you as opposed to horizontal, vertical, it's going straight at you. So that becomes your z-axis. When you get into calculus and that type of things, you actually get into the 3-dimensional realm. In this case, you just need to be able to solve for your x, your y, and your z. Okay? All right, so let's just do some practice problems here. So here we have a system. We have our first equation of x plus y plus z equals 2. Yeah, you can do elimination. I mean, I'm going to do elimination. You can do elimination or substitution. Yeah.
Can I see the first line? I'm sorry.
Just the tripled order. So your answer is going to be x, comma y, comma z. So in 4.1, it was x, y as an ordered pair. Now you're just going to throw a z at the end. Yep. All right, so we got our first equation, x plus y plus z equals 2. Second equation is x minus y plus 2z equals 2. And our third is negative x plus 2y minus z equals 1. So what I personally do, and I'm going to do for you guys so that when we're talking this through, we all know what we're talking about, I kind of put a number in front of them. So like I'm going to call this equation 1, this equation 2, this equation 3. So my first thought's going to be, can I eliminate any variables right off the bat? Y and 1 and 2 will cancel out. Good.
X and 2 and 3.
X and 2 and 3 will cancel out. And Z and 1 and 3 will also cancel out. Okay. There is no right or wrong where we start. Do you want to cancel out the X, the Y, or the Z? Y? All right. So that means we're going to combine equation 1 and equation 2 right away by just doing a simple adding. So bringing those together gets me how many X's? 2x. My y's go away. I'm going to be left with 3z is equal to 4. So since I eliminated my y, that means in order to solve for x and z, I need a second equation that also has x and z in it. Because to have 2 unknown variables means you need to have 2 equations. So I need to now incorporate in the equation I have not used yet, which is equation 3. And I need to try to eliminate my y in equation 3 with either the y in equation 2 or the y in equation 1.
Just multiply.
Again, there's no right or wrong answer. Me personally would pick 2 because this is already negative and this y is positive. So if this is a positive 2y, then what do I need to multiply equation 2 by? A positive 2. So if I double everything in equation 2, I'm just going to write it below. That gets me 2x minus 2y plus 4z is equal to 4. So we multiplied line 2 by 2. Okay. So now when I combine those, I get 1x, no y's, 3 z's, and 5. So now we can solve this. What do you want to eliminate?
We do substitution, just subtract.
You could do substitution, but even easier, notice your z's have the same coefficient. So I could just make negatives on my second equation. So make that a negative, 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 which results in 1x is equal to negative 1. So now plug this back into one of these two equations that we just used. Which one do you want, first or second? First, okay, so plugging in a negative 1 for x, 2 times negative 1 plus 3z is equal to 4. So negative 2 plus 3z equals 4. 3z is equal to 6. Z is equal to 2. So now I've got my x. Now I've got my z. The only other variable that I'm missing is my y. And in order to get that, I'm going to have to go back to the original 3 equations and pick whichever one you want. Which one do you like the best? Yeah, I like the first one because that has a little less stuff, right? So we said that x is negative 1. So I'm going to plug in negative 1 for x for equation 1. We do not know y, so that's going to stay minus y. My z we just said was 2 is equal to 2.
No, it's just plus y.
Oh yeah, thanks, plus y. So we get y plus 1 is equal to 2. So y is going to equal 1. So my final answer, x goes first, so negative 1, comma, followed by y, which is 1, comma, followed by z, which is 2. And technically, if I were taking my quiz on Thursday, I would plug these back into all 3 equations just to make sure they're all true, so that I know that it is accurate. So negative 1 minus 1 is negative 2. This gets me 4, so negative 2 plus 4 is 2, so that works. The negative 1 is 1, plus 2 is 3, minus 2 is 1. So yeah, so I know that I did it right. Now that one was pretty easy because things were eliminating right away. So let's do one that's not as nice looking with just coefficients of 1. Is everybody okay? Yep. All right. So number 2. We've got x plus 3y minus 6z equals 7. 2x minus y plus z equals 1. X plus 2y plus 2z equals negative 1. So again, I'm just going to put 1, 2, and 3's out in front so that when we're talking, we know we're talking about the same thing. All right, what are your thoughts? What do you want to eliminate first? X probably would be the easiest. Y, because if you look at 1 and 3, they both are 1x. So I could just take the negative of one of them. If I wanted to eliminate, let's say, y's with 1 and 2, I could do that and just multiply by 3, and I would cancel out my y's. If I wanted to eliminate z's with 2 and 3, I could multiply line 2 by negative 2 and cancel it out. So it'd probably be easiest just to make line 3 all negatives. I'm going to put little negative, 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 which changes that to a positive, and combine 1 and 3 together. So when I do that, my x's go away. 3y minus 2y would be 1y. Negative 6z and a negative 2 is negative 8z. And that's going to be equal to 8. So I eliminated x, which means I need to eliminate an x involving the third equation that I did not use, which is 2. So I either need to eliminate the x with 2 and 1, or I need to eliminate the x with 2 and 3. 2 and 3?
Yeah,
Okay.
multiply 3 by 2.
Well, okay, so we keep those all negative, sure. So if we double everything in line 3, keeping the negatives, that makes it become a negative 2x minus 4y minus 4z is equal to positive 2. So then combining 2 with my new 3, my x's go away. I now have negative 5y and minus 3z is equal to 3. You guys do elimination or substitution?
Substitution.
Okay, let's do a substitution. Why not?
And 8z.
Move that over. So that gets me y is equal to 8z plus 8. And I'm going to plug that in place of my y. So negative 5 times 8z plus 8 minus 3z equals 3. And again, you could have done this with elimination. I'm an elimination fan, so I would have just multiplied line 1 by 5 and canceled out my y's. That's okay. So negative 40z minus 40 minus 3z equals 3. Negative 43z is equal to 43. I did 2 steps there in 1. Is everybody okay with that? So I get z equals negative 1. Plug that back into the solved for equation. So z is negative 1. What's your y going to be? 8 times negative 1 is negative 8 plus 8 is going to get us 0. Good. So y is equal to 0. I've got a y. I've got a z. I need to get an x. Go back to one of the originals. 1, 2, or 3. Which one do you like the best? 1, 2. I personally liked 3 because it was smaller numbers, but we can go back to 1. So we're solving for x. That's going to stay an x. 3 times my y, which we said was 0, minus 6 times my z, which is negative 1, is equal to 7. So we get x plus 6 equals 7, so x is equal to 1. So my ordered triple is going to be 1, 0, negative 1. Okay. All right, so let's do one that's a little bit more difficult before we get to the special cases. Everybody okay? All right, number 3. We've got 4x plus 8y plus z equals 2. X plus 7y minus 3z equals negative 14. And 2x minus 3y plus 2z equals 3. All right, what do we want to get rid of first? There's no right or wrong answer. X. Okay, so if you want to get rid of x, the easiest way to get rid of x would probably be looking at 2 and 3. Multiply line 2 by a negative 2. So I'm going to rewrite that underneath 3. So that would get me a negative 2x. We're doing negative 2, right? So negative 14y positive 6z equals negative 14 times a negative 2 would be positive 28. So when you combine 3 with your new line, we get negative 17y plus 8z equals 31. Okay. So we did not use line 1 yet. So how could we eliminate x in line 1? Do you want to do it with 2 or do you want to do it with 3? 3? Multiply 3 by what?
Negative 2.
Negative 2? Okay, I'm going to write it above line 1 when I do that. So if I double everything with a negative 2 in line 3, I get negative 4x. I get doubling negative 2, so positive 6y. 2z times negative 2 is negative 4z. 3 times negative 2 is negative 6. So combining those two together, gets me, what is that, 14y minus 3z equals negative 4. Good. All right, so this does not look as friendly to eliminate, which means we're going to have to multiply both equations by a number. It would probably be better to eliminate the z's just because it would be smaller numbers. So what can I turn 3 and 8 both into? Yeah, it has to be 24. So that means I'm going to have to multiply the first line by an 8 and the second line by 3. All right. I feel like thinking this morning. So 8 times 14 is 112y minus 24z equals negative 32. 3 times 17 is negative 51y plus 24z equals 31 times 3 is 90. Why did I do that? 31 times 3 is 93, right? Okay, 112 minus 51 gets us 61. Y is equal to negative 32 plus 93 is 61. That ends up being nice. So y is equal to 1. What do we do next?
Just 14 minus 32 equals negative.
That's a
4.
z.
Oh, sorry.
I know, my 2's and z's kind of look the same. So 14 times 1 is 14 minus 3z equals negative 4. So negative 3z equals negative, 18. Why did I say 16? 18. So we get z is equal to 6. Good. Now go back to one of the originals. Which one do you prefer?
Number 2.
Number 2. Okay, I would have went 1 because there's no negatives in there, but that's okay. So 2, we don't know x. 7 times 1 is 7. 3 times 6 is negative 18 equals negative 14. Okay, so that really is x minus 11 equals negative 14. Add 11, so x equals negative 3. So negative 3, 1, 6. That's our ordered pair. Okay. That was the reason why it was more difficult is because we had bigger numbers that we had to deal with. But y'all have got calculators that can do the multiplication for you. All right, so you also might see something where there's gaps, such as this following system, where they might not have every variable in each equation. So this one has a 6x minus 12y equals negative 5. So this one already is missing the z. Here you have 8y plus z equals 0. So there's this gap of x. Here you have 9x minus z equals 12. So we're missing a y. So, how do you think you would do this one? Kyle?
Do you have to add the variables in?
What do you mean add the variables in? Like put in a 0?
No, I mean as in like.
Let's get our brains thinking in substitution mode. Could I solve for a variable very easily?
Z.
I could solve for z in the second equation, right? So that would get me z is equal to negative 8y. Down here in the third one, I could get z is equal to negative 9x plus 12. So then, what could I do with these two things? Since they're both equal to z, can I equal these two things together?
For the 9x, there's a negative sign behind it, so would that still, would it make it a positive 9 and then a negative 12? So
Oh, yeah. I totally forgot about that. Yes. because there's a negative there. So negative 9x plus 12, which would change all the signs to positive. Thanks for catching that, Maddie. So it would be 9x minus 12. You are correct. Good catch. So because these are both equal to z, I can set negative 8y equals 9x minus 12 equal to each other. So now look up here. Don't I have an equation that has an x and a y in it? Now don't I have an equation that has an x and a y in it? Yeah. So do we want to do substitution? Probably not, because if I divided that out by negative 8, then I'd get all these crazy fractions. So I would move this so that it looked like this. Yeah. So move that 9x over. So negative 9x minus 8y is equal to negative 12. Now let's bring line 1 down below that. 6x minus 12y equals negative 5. What could you turn 9 and 6 both into? 18, right, would be the smallest. You could go to 54, just deal with bigger numbers. So if I want to go to 18, I'm going to multiply my first equation by 2, multiply my second equation by 3. So now I get negative 18x minus 16y equals negative 24 for that equation. And then we get an 18x minus 36y equals negative 15. So that gets me negative 52y equals negative 39. Oh goodness, so 39 divided by 52 is 3/4. So y is equal to 3/4. Plug that back into one of these two original ones. First one? Okay. So if I do that, let me do this in a different color. Go green, go Christmassy. So negative 9x minus 8 times 3/4 equals negative 12. So 8 divided by 4 is 2. Times 3 is going to be 6. So we get negative 9x minus 6 equals negative 12. Negative 9x equals negative 6. 6 divided by 9 is 2/3. So x equals 2/3. Now go.
3/4 negative.
No, because a negative divided by a negative would go to a positive.
So it doesn't matter which equation you put.
Okay.
No, it should result in 2/3 either way. So now I have a y and an x. So now let's go back to one of these z's. I could go back to one of my originals, but I already have these solved for z. So it'd be easiest just to do, what, negative 8 times 3/4. So if we do negative 8 times 3/4, which will be negative 6, right? So my ordered triple is going to be my x, which is 2/3, my y, which is 3/4, and my z, which is negative 6. Okay. So if you see something where you're missing blanks, think substitution. Can I solve for one of the variables and then plug it in so that I end up with an equation with those two? All right, so we just have to finish up with special systems. So what happens when we get no solutions or infinitely many solutions and how we write that answer? All right, so go ahead and copy this one down. I just want to make sure this is one that is like that case. Yeah, so we have 2x minus 4y plus 6z equals 5. Negative x plus 3y minus 2z equals negative 1. X minus 2y plus 3z equals positive 1. we have anything eliminating right away?
Yes, the X is in number 2.
And 3, right? So I would combine those first thing. So combining 2 and 3 together results in a positive y plus z equals 0. So that means I need to eliminate the x with line 1 and either do line 1 and line 2 or line 1 and line 3. I would probably do line 1 and line 2 because they're opposite in sign. So what would I need to multiply line 2 by to eliminate the x's? 2. So I'm going to write that kind of small above. So negative 2x, doubling everything. So plus 6y minus 4z equals negative 2. So combining those gets me 2y plus 2z equals 3. Okay, what do we want to eliminate here? Y or z? Y? I went Y, sorry if you were going Z. So multiply by a negative 2, which makes me get a negative 2y minus 2z equals 0. So when we combine these two together, what happens to your y's? Your y's go away, your z's go away, and we're left with 3. Does 0 equal 3? No, so this is false. Which when we get a false statement, our answer is that there is no solution.
That just ends it right away.
Yeah. So those should be your best friends, right? Because a lot less work once you get to that false statement. All right, so let's do one that gets us a true solution. This will be the last example. So we've got 2x minus 3y plus 4z equals 8. Negative x plus 3/2 y minus 2z equals negative 4. 6x minus 9y plus 12z equals 24. So if you are getting anxiety right now because there is a fraction in that second equation, don't fret, get rid of it right away. What could I multiply equation 2 by to get rid of that fraction?
2.
Yeah, so just multiply by 2. Well, if I did the reciprocal, then I would have more fractions. But if I multiply what's in the denominator and multiply it by 2, then that's going to become negative 2x plus 3y minus 4z equals negative 8.
That kills 2 birds with one stone.
Yeah, because now what happens with 1 and 2?
You can eliminate with
Yeah.
1 and
So
2.
combining 1 and 2 together,
They all cancel.
so we get everything. So we get 0 is equal to 0, which is true.
Technically?
Technically. Doesn't 0 equal 0?
Yes, I think.
So, do you remember how we wrote our answers before? Don't write this, because just watch. Remember we did the set of x comma y such that, and then what did we put here in the blank? We wrote it in standard form, the most simplest standard form. Okay, well now we don't have an ordered pair, we have an ordered triple. So now it's x comma y comma z, so do put this down. Such that, now looking at our original equations, out of the 3, remember in standard form we can't have fractions, so number 2 is no good. Remember we can't have a negative x term, so 2 and 3 are okay, but I want the most simplest form, meaning can I still divide a number out of 6, 9, 12, and 24? Yes, so my most simplest form is equation 1, because I can't reduce 2, 3, 4, or 8 any further, so I'm just going to put that after my such that bar. 2x minus 3y plus 4z equals 8. And that's going to be your answer.
If we did choose the wrong one, like one that was in the simplest form, we would goes up.
Not as big of a deal.
Also, and if it's false, what's the solution again?
No solution. So just put your no solution sign.
Okay.
So the 0 with the slash through it.